Okay, so take 2 on the recording, so those that are absent can watch this later. Alright, so these were our steps we just talked about, and I'm going to go through this kind of slow again. So the first thing we do every time is move the constant to the other side. Guys, move the constant to the other side. So we're going to add 20 to both sides. So here we get x squared minus 2x equals 20. Now this is where we're going to complete the square. So right now what we have is not a perfect square trinomial. So when we take half this coefficient and square it and add that number to both sides, we have turned this into a perfect square trinomial. We have completed the perfect square trinomial. So then here we get, in factored form, this becomes x, what was half, minus 1, binomial squared, x minus 1 squared. This trinomial factors to this. That equals 21. We're going to take the square root of both sides, and you get plus or minus. And then the last step is to move our constant over. Now, sometimes, just like yesterday, we're going to get a perfect square under here. This case we didn't, but sometimes we do. Sometimes we're going to end up with just integer answers. Okay, questions about that one? Now, how do today's problems look different than yesterday's? Well, from here down, they look the same. So what happened was yesterday we started off with something squared. Yesterday we either started off with a binomial squared like this, or we started off with just an x squared like this. So there was no x in our problem that wasn't being squared. But today, do you see in problems like this, we're starting off with an x that's not squared. And when we start off with an x that's not squared, whether it's squared like this or squared like that, when we have any x that's not being squared, that's how we know we need to complete the square. So I know I need to complete the square on this one because this has an x that's not squared. All right. Step 1 was to move the constant to the other side. Well, in this problem, they already did that. The constant's already on the other side. So we can skip that step. Step 2 is to complete the square. What do I add to both sides? We take half
25
of 10, which is 5, and square it. So we're going to add 25 to both sides. All right, this is our third example. So go ahead and write that down. Okay, so after we take half the coefficient and square it, and we add that number to both sides to keep this equation balanced, then we can take this perfect square trinomial that we just created and write it as a binomial squared. What would this be? X plus 5, and that equals 18. So now I take the square root of both sides, and when I do, I get plus or minus. And just like yesterday, sometimes we have to simplify our radical. So you may be able to think of 18 as 9 times 2. You may need to take 18 and break it into the factor tree like this. And if you like it better like this, where you have to think, oh, it's a square root, so I need 2 of them to bring it out, that's fine. Either way, if you think of it like this and go, okay, I know the square root of 9 is 3. Or you think of it like this, and it takes 2 3s to come out. Either way, we get 3 roots of 2. So this equals plus or minus 3 roots of 2. And then we move the 5 over. So the correct form will always have the rational part of the answer first, and if we have an irrational part, it comes second. So if we have a square root, it comes second. The plain number comes first. Okay. So, do we kind of have the process down?
Yes.
All right. So now we're going to look at the 2 examples that might be a little trickier. One has fractions and one has a coefficient. So we're going to look at those 2 possibilities. And after we complete the square, guys, we're going to learn one more method for solving quadratics. And honestly, these next 2 examples that I'm about to do, I would never, ever, ever choose completing the square to solve it. I always choose what's the easiest, what makes the most sense. And the method I'm going to teach you next week actually is the easiest one for these kind of problems I'm about to do. So if we do these and they're kind of hard for you, it's going to take a little practice, but just know that next week, you're not going to have to solve these problems like this anymore. It'll make what we do next week make a lot more sense. So, what I'm about to show you is one that has fractions in it. So we've done completing the square with fractions. Some of you may be able to leave it as a decimal. Most of the time we write it as fractions. And so I know Mr. Bowen's class had to leave all of them in fractions. You guys are going to be better off because we can't leave a decimal under a radical. So those of us that dealt with decimals last time, we're going to have to figure out how to use fractions now too. Okay, so let's look at the first example. So it's the same exact process. I'm going to switch variables just because we don't always have to use x. I'm going to use m this time. Okay. I can tell that I need to complete the square because there's a plain old m. I have an m that's not being squared. So I know it's not what we did yesterday. I know I need to complete the square. And the way I do that, step 1 is always move the constant to the other side. Okay. Now when we take half, do you see when I take half of this, I get, and we wrote it as a decimal before.
No, you just
Now we just want to leave it as 9 halves.
and then square it.
And when we square it, 9 squared is 81. 2 squared is 4.
Did you always leave it over 2?
When we take half, it always ends up being over 2, yes. Okay. All right. Here's the cool thing about your calculators. If you're not good with fractions, punch it in your calculator. 9 divide by 2, enter, and then square it. And did you guys know that even the graphing calculators will turn a decimal into a fraction for you? So after you do 9 divided by 2, it's going to turn it into 4.5. And when you square it, it turns it into 20.25. But then when you hit the math button, and then the fraction button, and enter, it turns it to this for you. Okay, so once again, those of us that are not good with fractions, what we're going to do is punch in 81 divided by 4 plus 7, math fraction enter. Now, the little calculators, like Zeta has, any of you guys that have these, they actually have fraction buttons on them. So the little calculators are easier to manipulate with fractions than the graphing ones are. I think that would put in fraction mode though. Okay, so if we add these two, this is the old way you learned how to do this in like, let's see, 4th grade, I think. You turn 7 into 28 over 4, because what's 28 divided by 4? 7. And 28 plus 81 is 109. Okay, but I do not want you to spend a lot of time trying to figure out arithmetic. Use your calculator. Use it. All right, so that's what we get over here. So then over here, this becomes m minus 9/2 squared.
Square it.
And then we take the square root. And this is why we couldn't leave it as a decimal. Right here. We can't have a decimal under a radical. So, whereas before, when we did vertex form, decimals were okay. They were okay. Here, they're not okay. It's against the math rules to leave a decimal under a radical. So, the square root of 109, we don't know it. But we do know the square root of 4. 2. So it becomes the square root of 109 over 2. And the last step is to move the 9/2 back over. Yeah. So my answer is m equals 9/2 plus or minus square root 109 over 2. All right, I'm not even going to try to come today to have a coefficient. We're going to do one more that has an odd. Let's do a U try with an odd. Okay, so I'm going to give you a little bit smaller numbers for your turn. X squared plus 5x plus 2 equals 0. And my directions are to solve for x by completing the square. I'm going to end the video here, but I'm going to post the notes on my website, and I'm going to show all of you guys the website again, in case you're absent. There's been lots of sickness running around, and I'm going to try to record every day and post my notes every day. And hopefully that'll be helpful, because I don't know if your regular math teacher does YouTubes, but I'm going to start doing YouTubes at this class every day. So there's just been a lot of people out from illness.